Hey guys, this side Anirudh. I'll be your trainer today. So we have few sessions that we already gone through for BGP. So welcome to the next session. Let's go on.
And how is it possible to receive same prefix from two times from the same neighbor? No, it's not receiving it from the same neighbor because next hop is not. Next hop will never get changed in IBGP. That is why when R2 given this prefix to R5 and R6, R5 and R6 both of them are also giving it back to R1. Hey, R2 have advertised these prefixes towards R5 and R6, and then R5 and R6 both of them are giving it back to R1 without modifying their next hop address. And that is why it is really good for us that next hop address was not changed, so that whenever you will start to go from R1 to R2, you will directly go in the direction of R2. You will never go via R5 or via R6 in this physical diagram. It's not it. Whenever you will require to ping or whenever you will require to transmit your data from R1 to R2, it will directly go in the direction of R2. And you see that from R1 which one is best. This one is best. And now by looking at BGP table, you cannot decide that whether via R5 it is best or via R6. To know that, actually you have to open it in more details, like 20.1.0. check it out. Lower neighbor router ID. This is best, but doesn't matter which one is best because it has to go through exactly directly. It has to go directly towards R2 because next hop is common via both neighbors, right? But the problem is this time, see, if you move on R6, if you check BGP table of R6, this is the problem now. Like 10's prefix is coming from R1, but also it is given from R5 as well. Let me show you on R6. Show IP BGP 10.1.0. It's coming from R1. That's good. That's very good that it is coming from R1. But why it is coming from R5? See, it means that this time in a single cluster you are having same cluster IDs on R5. Sorry, different cluster IDs on R5 and R6. That is why R6 is receiving prefixes coming from R5. That is why R6 is receiving prefixes coming from R5, and R5 will also receive prefixes coming from R6. It should not happen because all of them are in a single cluster. So do one thing on R6 and R5, configure common cluster IDs now. So say BGP cluster ID is like 5.5.5 on R5, and on R6 also I'll configure the same one. Router BGP 65500. BGP cluster ID is what? Sorry. And now show IP BGP. Check it out. It have stopped to receive anything from R5, but still you will see that it is receiving one prefix from R5, which is 50's prefix. Of course it will come. And remember that if route reflector advertised its self-advertised prefix to its neighbor, it will not add those two attributes. Try to understand. If route reflector is advertising its own prefixes, it will not add those two attributes like originator ID and cluster list, because for its own prefixes it is not working as a route reflector. It is working route reflector only for those prefixes which have been received from its IBGP neighbor. So when R5 will advertise its own prefix information in the direction of R6, it will not add information. It will not add those two attributes. That is why R6 is still receiving the prefix of R5. See, 50's prefix. So IP BGP 50.1.0. You will not find anything like cluster list or originator ID in it. Do you have that? But if you open show IP BGP, because this time you are receiving it from client, R6 is receiving it from client. So in it you will see that
received from
RR client, and whenever it will advertise it towards any other neighbor, before advertising it towards any other neighbor, it will add those two attributes. Like you do one thing, move on R2 and you open show IP BGP then .1.0, which is given from both of them. See, when it is given from R5, then in originator ID it is the router ID of R1 because R5 got it from R1 itself. But in cluster list, R5 have added its own cluster ID. It is also receiving the same prefix from R6 as well. It is also receiving same prefix from R6 as well. Originator ID is same, but unclustered list is also given from R6. So it has proved that whenever route reflector will receive any prefix from one of the client, will advertise it towards any other client, it will add these two things. But if it is advertising its own prefix, it will not add that. Like on R2 itself, if you open show IP BGP 50.1.0, see, if it is coming from R5, see, if it is coming from R5, this entry is from R5, right? It is not having those two attributes here. But if it is receiving it from R6, because R6 got it from R5 and then further R6 is giving it to R2. So it has added those two attributes now, originator ID and cluster ID. So there will never be any routing loop, never ever. And this is the uses of redundant route reflector, right? So in this way they are performing. So in case if any one of the router goes down, then also there will not be any problem. Like let me do one thing. On R5, what will I do? I'll say neighbor CCIE is what? Because it was my peer group, if you remember. So all of them will go down now. But still they are having neighborship with R6. So still they will be having each other's prefixes available inside their BGP table, you see. Have you understood it or not? So this is the advantage of having redundant route reflector. But remember, in a single cluster means all route reflectors in that cluster must have same cluster ID. Move on R5, say no shutdown. Once again neighborship will come up. So in this way you can configure route reflectors with one redundant route reflector. Let's go for another diagram, and this time I will modify this diagram. This time I will be having two different clusters. This time I will be having two different clusters in this way. Like I'll be having R1. R1 will be having neighborship with R2, with R3 as well, in this way. Then R1 will be further connected with R. There is no R3, so I'll be taking R4. So it will be further connected with R5, and R5 will be connected with R6. So I'm having one. Like I'll define it in a single cluster and I'll define it in a single cluster. So I'll define this R1 as a route reflector, it will be client, R5 as route reflector, it will be client. But for R5, R1 will be non-client. For R1, R5 will be non-client. This is R5, see. So this time these two route reflectors must have different cluster IDs. If they are having same cluster ID, then of course there will be a big problem.
Routes will not go.
Exactly. Are you getting my point or not? So in this way you can define here route reflectors at advanced level. So let's do one thing once again, remove this BGP from all devices. Fine guys. Let's configure it once again. This R1. Remote AS is what? Update source. Then neighbor is what? Right? And neighbor is and then update source is networks and .1.0. This is R1. R1 is having neighborship with R2, R4 as well as R5. So that's what I configured on R1, right? Then move on R2. On R2 it is having neighborship with R1 only. So router BGP. Neighbor. Neighbor is configured. Now advertise your prefix. Fine. In same manner you have to move on. Router BGP 65500 neighbor. Remote AS is, and then you have to define your which is, and then finally
So these topics will be covered in CCA. What should
everything. Fine guys. So now let's move on. R5. So we have to configure R5 as well. Say router BGP 65500 is having neighborship with 150.1.1. Remote AS is what? 65500 and update source is loopback 0. Then neighbor 150.1.6.1. Remote AS is what? 65500 and update source will be loopback 0. And then network 50.1.0. And finally move on R6. Router BGP 65500, neighbor 150.1.5.1, remote AS 65500, update source is loopback 0 and network 60.1.0 mask will be. So now this time you will see, because I have not configured any router as a route reflector, so R1 will be having prefixes coming from R2, R4 as well as R5 because they are directly connecting neighbors. They are directly IBGP peers, right? But R1 is not gonna to advertise prefixes coming from R2 and R4 in the direction of R5. And also if R1 is receiving anything from R5, it will not advertise it towards R2 as well as R4. Even R1 won't be able to exchange prefixes in between R2 and R4. Fine. Check it out. Only R5 is prefix. If you move on R5, R5 will be receiving prefixes of R1 as well as R6. If you move on R1, then it will be receiving prefixes from R2, R4 as well as R5. Check it out. Okay, it means R4. On R4 I didn't advertise. Okay, I didn't configure. Router BGP 65500, neighbor 150.1.1.1, remote AS is what? 65500, update source is what? Loopback 0 and network 40.1.0 mask will be. See, is not it? Now there will be requirement of configuring route reflectors. Of course, without route reflectors, you cannot exchange routes in between them. So do one thing, move back again on R1. Router BGP 65500, neighbor 150.1. What? Tell me, if you want to configure R1 as a route reflector, what will be your command?
R2 or
So neighbor, tell me what? Then
4.
fine. Now you will see that it will start to exchange prefixes in between R2 and R4. So if you move on R2, it must get R4s as well as it have also received R5s, but still it have not received anything from. And you see, so BGP 40.1.0. Originator ID is the router ID of R4. Cluster list is having router ID of, cluster ID of route reflector, which is R1. Even if you open so BGP 50.1.1.0, you can see the same thing. Now on R5 also you will get everything, because R1 can advertise towards non-client everything, right? So on R5 you are having everything, but R5 will not be able to advertise it towards R6 now. It means that on R6 you can get anything without configuring this R5 as a route reflector. So now you do one thing, move back again on R5 and say router BGP 65500 and neighbor 150.1.6.1 is what? Route reflector client. Once you will configure it as a route reflector client, you will see that on R6 all prefixes will be available. Check it out. Even now on R1 or on R2 actually, on R2 you can also get R6 prefix as well. See, and if you open it now, so IP BGP 60.1.0, check it out. See, cluster list is having now, whereas originator ID is still same.
Yeah.
It's not it. So in this way, route reflector works. Originator ID is same as previously. Like of course, this prefix was received on route reflector R5 from R6. So R5 put its originator ID as the router ID of R6 because R5 received them from R6 itself. And then you see cluster list. It has been prepended by, cluster IDs have been prepended by route reflector. So first of all, it was prepended by R5 because R5 was the first route reflector, and then got it. In same manner, you can move on R6. You can also open prefix coming from R2. Originator ID, cluster list. Now if you configure their cluster IDs same onto R1 and R5, then they will not be able to exchange prefixes with each other except their own, right? So you do one thing, move on R1 now. Router BGP 65500, BGP cluster ID, BGP cluster ID, and then let's say, and same I'll configure on now. R5 will not receive any prefix coming from R1, reflected by R1. See, 20s and 40s prefix is not there. Understood? Any problem now? So in T-shoot, they can do this. they will be having two different clusters, and on both route reflectors they will configure same cluster IDs, and you will see that they will not be able to exchange their prefixes with each other. So you have to be very careful. So on R5, once again I'll move there and I'll configure BGP cluster ID as 5.5.5, and once again you will see that. See, everything is there. So in this way you can configure route reflectors at large scale. I mean, now you have understood everything that happens in the behind of route reflectors actually. So basically route reflectors are playing with the help of originator ID and cluster list only. And whenever these updates will go out from, like if I configure neighborship in between R6 and BT, then you will see, let me configure it, that these attributes will be stripped from outgoing updates. So router BGP 65500, neighbor is 201.100.100.1, remote AS is 35500. So it will form neighborship with BT, and also it will advertise those prefixes in the direction of BT now. Let me show you. Show IP, BGP, something. It have came up now. It have received all those prefixes. So IP BCP 10 dot, or you can say 20.1.0. Does it have any information like originator ID or cluster list? Fine. Understood? So in this way you will configure route reflectors. Now let's go for configuration. So once again let me remove BGP from all these 6 routers. I mean 5 routers actually. Fine guys. Okay, so this time I'll be drawing this diagram in this way actually. Like there is R5, R1, R2, R4, R6. And then R5 and R6 are having neighborship with BT. Fine. So these 5 routers are participating in this main AS 65500. But what will I do? I will create some sub ASs. On R5 I will use AS 655, or you say AS5 only. On R1 I'll use AS1. On R2 I'll use AS2. On R4 I'll use AS4. On R6 I'll use AS6. So this time I will not use route reflectors along with configuration. This time I'll be configuring only and only configuration. However, it is always you will always find in production networks that you will be using configuration along with route reflectors. So basically you will be using configuration just to reduce total number of route reflectors in your network, right? So but this time see, all of them will be eBGP, configured eBGP neighbors, right?
Yes.
So I'll show you that most of the features are from iBGP neighbors, but some of the features are also from real eBGP in configured eBGP, right? So let's do it now. On R5, I will start from R5. Router BGP, I wanted to configure 5. Now you have to tell this router that this is your main AS, primary AS.
Okay.
Like BGP configuration identifier. With using this command, you will tell your router, your BGP, that this is your main AS, primary AS, which was 65500. Now, say neighbor 200.105.100.1 remote AS is what? 3550, which is eBGP BT. You will see neighborship will come up. See, however, you have configured AS 5.
Yes, sir.
Did you configure remote AS 5 on BT? On BT still you are running remote AS as 65500. I have not modified any configuration, any initial configuration of BT.
Okay.
Then say neighbor 150.1.1.1. One more thing. If you are having your config eBGP neighbor, and if it is config eBGP neighbor, it means it will be in different sub AS.
Okay.
So if you are having your neighbor in different sub AS, then you have to configure this command as well. BGP configuration peer, and then you have to tell those sub ASs in which your peers are existing. So this time I'm having only one sub AS in which I'm having my peer, which is only one, and then define neighbor 150.1.1 remote AS is what? 1. You have to tell about your sub AS only.
Yeah.
And then neighbor 150.1.1 update source is what? Loopback. But it still do show IP BGP summary. Let me show you that it will remain in ideal state because TTL. Due to TTL, because it is also having some features of real eBGP. So you have to change your TTL value as well. So say neighbor 150.1.1.1 eBGP multi-hop is like 2 or 3, whatever it is, right? Now do show IP BGP summary. You will see that your neighborship will move from ideal to active. Now move on R1. Router BGP is what? BGP configuration identifier is what? 65500. Then BGP configuration peers. This time R1 is having peers in two different ASs. One is 5, which is R5. One is 2, which is R2. And then after say neighbor 150.1.5.1 remote AS is what? 5. The neighbor 150.1.5.1 update source is loopback 0. The neighbor 150.1.5.1 eBGP multi-hop is what? And the neighbor, sorry, network 10.1.0 mask is what? Are you getting my point or not? Move back again on R5 as well. Even on R5 also you can advertise 50s network. Understood? Then you do one thing, move on R2 now. And on R2, say router BGP is what?
2.
BGP configuration identifier,
655.
which is main AS. Then BGP configuration peers. You have to specify those sub ASs in which you are having peers. 1 and 4. Neighbor 150.1.1.1 remote AS is what? 1. Neighbor 150.1.1 update source is loopback 0. Neighbor 150.1.1 eBGP multi-hop is 2. Neighbor 20, sorry, network. Okay, you are also having one another neighbor. Neighbor 150.1.4.1 remote AS is 4. Neighbor 150.1.4.1 update source is loopback 0. Neighbor 150.1.4.1 eBGP multi-hop is what? Network 20.1.0 mask value will be then you can also move on. Router First of all,
655
BGP configuration identifier 65500, then BGP configuration
here 1 and 6 2 and 6.
You understand? And before going to configure this R4, let's move on R1. Let me show you BGP table of R1. So IP BGP. See, these prefixes, 50 prefixes coming with local preference. However, it is eBGP anywhere, but this time it took this feature from iBGP. And also next hop have not been changed, and that is why these are not best via from R1. See, because R5 is advertising them towards R1 without modifying next hop. So this feature was also taken from iBGP. So you have to move on R5 and neighbor 150.1.1 say next hop. Now you move back again on R1. It's best now. And now it will also advertise. See, for R1, R2 is eBGP, config eBGP. Let me show you. Show IP BGP neighbor 150.1.2.1 on R2.
R1 पे R2 के साथ नेबर
Router BGP 1 neighbor 150.1.2.1 remote AS is what? 2 neighbor 150.1.2.1 update source is loopback 0 neighbor 150.1.2.1 eBGP multi-hop is what? Wait. Yes. See, again next hop has not been changed, but this time it is reachable. There will not be any problem because it is in a same AS, right? And let me show you. See, these prefixes are coming after crossing two sub-ASs. Sub-ASs will always be mentioned in brackets. Sub-ASs will always be mentioned in brackets. See? So R2 will defined, will make them as best very soon. See? It's best because this time next hop addresses are reachable. But if you open show IP BGP like neighbor 150.1.1, so it will show you what is it showing you. But thing is show IP BGP 192.168.100.0 config external, right? So this is config external for R2 because it is receiving it from config eBGP neighbor R1. Hello, this is config eBGP neighbor, right guys? So in this way you can configure configuration, fine. And then after, and remember that these sub-ASs will never participate in your best path selection in BGP.
Yeah.
These sub-ASs will never participate in your BGP best path selection, fine. Now you do one thing, move back again on R4. BGP configuration peers are in 2 and 6. The neighbor 150.1.2.1 remote AS is 2. Then update source is loopback 0. eBGP multi-hop 2 or 3 would be enough. The neighbor 150.1.6.1 move on. Router BGP in 4 only. Is not it? And then neighbor fine. You have to configure next hop self as well over here. Otherwise, it will receive prefixes from eBGP neighbor, will advertise towards config eBGP neighbor without modifying next hop. It have received it from there. It will advertise, see, it is also receiving it from 5. Next hop is 5 because next hop will never get changed. However, it is receiving this prefix from R4 because for R4 its best path will be definitely via R5 because via R6 it's not reachable. Next hop address is not reachable. Even you can go there on R4, you can check it out. See, 192's prefixes. Next hop is not changed. So do one thing, move back again on R6 and configure 150.1.4.1. next hop is what? Self. Once you will configure this command, now move back again on R4. Show IP BGP. Now its best path is via, still it is via R5. You know why? You can check it out. Show IP BGP 192.168.100.0. First of all, is metric from R4. It's just 2. Is not it? So basically these sub ASs are not participating, otherwise via R5 it has to across 3 sub ASs, whereas via R6 it has to across only 1 sub AS. So remember that sub ASs will never participate in your best path selection. But ICP cost, see, to reach next hop. Understood? Hello?
Yes.
So this time you are not required to configure route reflectors, and you can see that all of them have exchanged prefixes with each other. You can see that on R4 you are having all prefixes. See, 20, 10, 20, 40, 50. You can also have 60 because 60 I think I didn't advertise it on R6. That is why you are not receiving here 60. But you can see that 50's prefix is there. So here you will not require to configure route reflectors, and in this manner your configuration will work. So as you have seen that some of the features, I mean for config eBGP, some of the features were taken from iBGP and some of the features were taken from real eBGP. But remember that for config eBGP, you will see that local preference will always be part of your BGP updates. Is not it? Like see, they are coming from eBGP, but local preference is still there because they are config eBGP, they are not real eBGP. So whenever BGP will give any update to its config eBGP, then definitely it will add information. It will carry local preference in its BGP updates. Understood or not?
Yes, sir.
So this is all about the configuration. In this way you can configure your configuration. But remember, along with configuration also you can configure, because you can put multiple routers in a single sub AS as well. So if you are having multiple routers in a single sub AS, then you will require to configure route reflectors. So I don't think so that it is necessary for me to perform that practical as well. You people can do it now by yourself. And remember, inside configuration that you configure this command, peer command, will be configured in that case only when you are having neighbors, your config eBGP, your neighbors in different sub AS. If your neighbors are in same sub AS, then you will not require to configure this peer command. Understood? And see, whenever updates will go out from its own AS, these sub ASs will be stripped from outgoing updates whenever it will give those updates to its real eBGP neighbor. So let's move on BT now. Check it out. These 10s, 20s prefixes are coming from there, right? So IP BGP 10.1.0. Check it out. Nothing, no information about the sub ASs, right? So this is same as like private VLANs. Have you understood it or not?
Yes.
So that's all about route reflectors and configuration. So tomorrow I will complete your communities, and then after communities, maximum 1 or 2 classes will be required for BGP. Most of the part of BGP will be covered in tomorrow's class. Then after we will be having some small practicals, but really important in BGP. Right?
Thank you so much, guys, for watching my video. So we'll be coming back with few more videos of the BGP. Please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you in next video.